out what is FRR. Quickly do it and type your answer in the chat box. Into G, 9.8 into cos 3 degree. Unit is Newton, right? So it should come around 176.16 Newton. Let me check whether you got same answer. Right, so more or less everyone is getting same answer. Alright, so I think we are done for the first part. Now let's talk about the second part. Okay, second resistive force is aerodynamic drag force. So you must have felt that when you are driving a vehicle, if the wind is coming in opposite direction, right, you have to give more effort. Whereas if wind comes from your backside, that generally helps you to propel or generally to move. And also, when a vehicle is in motion, right, it has to overcome the air pressure which is acting opposite in direction to the vehicle movement. Basically, you have to overcome this concept called aerodynamic drag. So this aerodynamic drag is calculated by this interesting formula. F aerodynamic drag. Let me try to write in a bigger font. Sorry. So this F aerodynamic drag is given by half. Half, that means 0.5. It's a constant number, right? Into rho. Rho is nothing but air density. Air density, or density of the air in kg per meter cube. Okay. So as you know, as we go higher to higher, air density will be less, right? So typically for ground level things, we can take air density to be 1.2 kg per meter cube or 1.15 kg per meter cube. As you go higher, air density comes down. So 0.5 rho, third is AF. Again, AF means the frontal area of the vehicle. Now there is some confusion on this. Because a vehicle may have different, front shape and areas, right? So what do you consider? So think of it, when you're looking to a vehicle from its front size, you're going to see some width, some height, right? So that multiplication, so that will be frontal area. So it is multiplication of width into height, right? Looking from the front side, what you see, how much is the width of the vehicle and how much is the height. Height means generally not only this, I'm talking about this height, okay? This entire height. And width is also, you can see from front, if you see it, approximately wheel side to wheel side, that is the width. So if you multiply them, you get the frontal area. Then comes CD. CD is again a coefficient for aero drag. Okay. And then comes V square. V square is basically the speed of the vehicle in meter per second square. And frontal area unit is meter square. So again, take a note. Let me repeat again. Aerodynamic drag is given by 0.5 rho. Rho is air density. Then into frontal area of the vehicle. Then CD. CD is aerodynamic drag coefficient. It will be a unitless number like we had mu. And then V square. V square is the vehicle speed square in meter per second square. Okay. Now, how do you get this value of CD? So again, depending on frontal shape of the vehicle, CD is going to have different values. Right. The value of CD, lower is better. So as low possible CD, that means you have a better design, right? So basically, for simplicity, you understand, right? If your aerodynamic drag has to be reduced, the value of CD must be low. And this CD depends on the frontal shape, the design of it, right? So you can see that generally for high-speed vehicles. So aerodynamic drag is since aerodynamic drag is kind of proportional to vehicle speed square, you may see it looks like something like this. So this is a problem generally at higher speeds. Okay, so aerodynamic drag comes into picture mainly at the higher speed. At lower speed, its effect is almost negligible because it is square to the vehicle speed. That's the reason you can see those low speed vehicles, typically less than 50 km, 25 km, their front area generally is blunt in nature, not sharp. Because for them, aerodynamic drag is not a problem. But if you go with very high speed train, the Formula One racing car, or in general any very high-speed vehicles, their front will be always sharp in nature. By doing that, they basically reduce this value of CD. Okay. For example, you must have seen the frontal area of Vande Bharat versus any of the local trains, or typically the old high-speed trains also. So their previous trains, they have a front blunt shape, right? While the very high-speed trains like bullet trains, they will always have a sharp nose at the front. So why we do that? Basically to reduce the value of CD. Okay. So for example, look at this particular vehicle. It is a very sharp edge, right? It is a very smooth design, and you can see its value of CD is pretty low, around 0.2. Whereas you talk about this van kind of body, it is a kind of blunt face. Okay, so it is around 0.5. So I hope you understand the importance of aerodynamically good design, which is used for high-speed vehicles. Okay. So again, please note down the formula. We are going to solve the problem. I saw some of you requested for a zoomed version of the problem that I'll take care. Please note down the formula quickly. I hope you have noted down. You can quickly note it down, or you can take a photo also. All these contents are already there in your that PDF, which is shared by the IntelliPad team. So with this, let us try to solve the problem. So problem is that if I most probably I won't be able to make it very high size for you. Still, let me try.
वो तो हम देखला तो हमर गलती नहीं है, गलती मेरे तो और कहना मैं थोड़ा फोन में पढ़ूंगी, मेरा तो कुछ हो गया मैं भी छोड़ती नहीं, मेरा नाम भी हर बार यही करता, हर बार.
I hope this will help. So please try to understand. It is slightly not easy to read, but I hope you'll get the idea. So what you have to do, you have to read this line, then this line, right? So a passenger aircraft is cruising at an altitude where the density of air is 0.7 kg per meter cube, right? So value of rho is given. For your reference, the formula was FAD 0.5 rho AF CD V square, right? So the value of rho is given as 0.5 into 0.7. The value of rho we have kept. The aircraft has a of 100 meters square. So this is nothing but the frontal area, 100 meters square. Okay. The value of CD is given here as 0.025. 0.025. Okay. If the aircraft is flying at a velocity of 250 meter per second, so your vehicle speed is given as 250 meter per second. So we're going to take a square of that, and then we're going to get the value of aerodynamic drag. Okay. So CD is given. Velocity is also given. So quickly, please find out what is this aerodynamic drag. Later on, you'll see we can also apply the same thing to a vehicle. For time being, quickly calculate it and give me the answer. So what you have to do is simply keep all the values and put it into calculator and give me the answer, right? One answer, of course, what I got, I have given so that you can match. And that's how we'll be able to complete this task. Of course, if you have any doubt, let me know. Okay, so most of you are getting it correct. Only Shamim Alam, I think there is some calculation issue. Otherwise, most of you are getting correct answers. Okay, if you're putting it kilonewton, then that is also okay. So I think it is clear, more or less. Then let's go to the next part. So there are two, in general, even if there is no active air in that, or rather wind blowing in the area, still your vehicle has to overcome the presence of air. And if there is presence of wind, right? So the wind can help you if it is coming from behind, and the wind will give more position if it is coming from the front side, right? So if you have some active wind in that driving area, for the vehicle speed, effective vehicle speed, you add that speed of the air. Of course, you don't easily measure the speed of the air for any problem purpose, etc. Right? I hope you're getting it. Let me again repeat. Let's say you're driving a vehicle and there are additional wind coming into it. So that additional wind from the frontal side, that adds more aerodynamic drag to the vehicle, right? So in that case, How to account for that wind? Speed is that speed of vehicle plus speed of air that we put into this equation. Okay. So due to this more headwind that is coming from the head side or front side, that gives more opposition. That's why effectively aerodynamic drag will increase. And on the contrary, if you have a tailwind, that means wind is coming from the back side, that will help your vehicle motion, right? So in that equivalent speed, you subtract the speed of air or speed of wind from the vehicle speed for calculation purposes. So with this, let us move ahead with the third case. Third is gradient resistance force, or sometimes we call it hill climbing force. Hill climbing or gradient. Okay. So as the name suggests, when you're going some uphill, naturally you have to give more tractive force, right? Because you have to overcome an additional resistive force as compared to a flat road. So when you're going some uphill or downhill, right? Especially for uphill, you need to apply more tractive force to overcome the additional force, which we call it gradient resistance force. So this gradient force, how do you calculate? Is mg sine alpha, right? So if you are going uphill, as compared to flat road, if you are going uphill, alpha is going to be positive. And if you are going downhill, this is flat road. If you are going downhill, right? So then alpha is going to be negative. I hope this point is clear. So that means when you are going uphill, more resistive force. When you are going downhill, actually that helps you in the tractive force. So how do you calculate? Very simple, mg sine alpha. You already know what is m, you already know what is g, and then third is sine alpha, right? Alpha is the gradient angle. So with this, let us solve this problem. In case you are finding it very small in font, let me repeat. There is a car with a mass of 1200 kg. That means m is 1200 kg. Okay, is traveling uphill. That means alpha is positive on a road with an inclined angle 8 degree. That means alpha equal to 8 degree with respect to the horizontal. Calculate the gradient force experienced by the car. So FGR equal to mg sine alpha, and unit is Newton. So you already know all the values. In case you forgot, G generally we are going to take 9.8 meter per second square, right? So put all the values and give me the answer quickly. I hope you'll be able to do it very quickly. Let me see your answer. Okay, I think almost all of you are giving the same answer, that Larikaji is correct. Okay, so there is a question in case we have a vacuum tunnel. Yeah, in vacuum tunnel, your aerodynamic drag will be almost zero, if it is ideal, of course. But FR is the friction between tire and the road. So as soon as there is some tire and road contact, there will be, of course, some friction involved. So I think all the answers are correct. Thank you again. Thank you so much for supporting this problem session. So the answer I had got also was on the similar line, 1636.68 newtons. Okay, so with this, we know approximately how to calculate 3 resistive forces, right? So then, total resistive forces will be summation of all these 3. So do remember, total resistive force. We can say force, maybe R, that is resistive force, is summation of F rolling resistance plus F aerodynamic rate plus F gradient force. Simple. And how much tractive force we need? Tractive force required is this rolling resistance, total resistive force plus mass into acceleration. This is missed in the study material. Please add a note on that. Okay. So remember the Newton's second law, as I told earlier, what it says, F tractive minus F resistive equal to mass into acceleration, right? So that means from this we can derive the tractive force required is rolling total resistive force plus mass into acceleration. For example, let's say when you want to start the vehicle from 0 speed, you need acceleration, right? Otherwise vehicle will never move. So this acceleration requirement also puts additional requirement on the force requirement. So basically force will come from motor eventually, you'll see. So motor rating also get decided by your acceleration requirement. For example, you see some vehicles, they claim 0 to 100 kilometer in 5 seconds, 0 to 60 kilometer in 3 seconds. What are these? These are nothing but acceleration requirement, right? So 0 to 100 kilometer, that means change of speed, right? Let me write down in case here. 0 to 100 kilometer per hour in, say, 5 seconds. What does it mean? It means 0 to 100 kilometer is nothing but dv, change of velocity, right? 0 kilometer per hour to 100 kilometer per hour. So it is nothing but dv. Remember, any variable dv, what does it mean? It is a change, right? So it is kind of v2 minus v1. v2 is the final speed, v1 is the initial speed. So, and then dt, it indicates change of time. That means t2 minus t1. So if a vehicle has a speed v1 at time t1 and a speed v2 at time t2, I hope you understand what is dv, what is dt, right? v2 minus v1 is dv and t2 minus t1 is dt, right? So 5 seconds means here in simple 0 to 5 seconds, right? So you start with 0 second. In 5 seconds, you must reach 100 kilometer per hour. So basically here they are mentioning dv dt, which is nothing but acceleration, is 100 by 5. 100 it is kilometer per hour and it is in second. So of course you have to convert them into same unit, right? Hour and second, they are not of same. So hour you have to convert into second. Then you'll be able to make the. So what I'm trying to say is kilometer per hour. How can I convert into meter per second? So 1 kilometer we know is 1000 meter, right? I hope I'm correct. And 1 hour means 3600 second, right? So this is how we can find out how to convert kilometer per hour to meter per second. Don't worry, we are going to solve some problems also. So quick summary, force required is total resistive force plus acceleration requirement. Higher the acceleration requirement, logically you see you need more force, right? That means you have more motor ratings. So there is a quick problem to solve. It's a very easy one. Again, I'm not very sure whether you can read it, but I can help, no problem. So they say a car is traveling on a straight road. The rolling resistance force experienced by the car, FRR, rolling resistance is 150 Newton. Additionally, the aerodynamic drag is 100 Newton. So F aerodynamic drag is 100 Newton. Okay. The gradient force due to slight incline is 50. So gradient force is 50 Newton. Okay. Calculate the total traction force required at the car's drive wheels. So they say F tractive equal to how much? Required F tractive equal to how much? So as we know, F tractive required is nothing but Fr plus mass into acceleration, right? Here, acceleration requirement is not given. So Fr we can simply get from this summation. So it is nothing but 300. Okay, and then mass of the vehicle into acceleration requirement. That if you do it, you are going to get the answer. So it depends on which vehicle you are doing it. For example, let's say a vehicle like Tata Nexon, right? Approximately mass will be around 1400 kg. For any vehicle you see their data sheet, you will going to get the information on mass, right? At the same time, the target acceleration, that also you know, right? Some vehicle they mention, as I told, 0 to 100 km per hour in 5 seconds. So from that you calculate this mass into acceleration requirement. Always note, mass you have to put in kg, acceleration meter per second square. All right. So you put them, you're going to get the answer. So that you can take as a homework. Let's say 0 to 100 km per hour in 5 seconds. Okay. Convert it into A is how much in meter per second square. That's it. You're going to get it, right? Okay. So till now we are talking about force. But for motor, as you understand, we have to convert everything into torque, right? And we also understood how force and torque are related. Torque is nothing but force into distance, right? So that also we discussed earlier. Torque is nothing but force into distance in simple terms. Force in the Newton, distance in meter. So torque will be in Newton meter. Okay. So to move the vehicle, we need to provide a torque at the wheel, isn't it? So how much torque we have to apply to the wheel? See, first what we are going to do, first we are going to calculate how much force we need at the vehicle level. Then you multiply with RR. What is RR? Radius of the wheel. That's how you're going to get T wheel. That means torque at wheel. And from that, we are going to calculate torque at the motor. Simple. So from the vehicle requirement, from the resistive force calculations, we are going to find out how much is the tractive force requirement. With that, we are going to multiply rolling resistance, right? Rolling radius, basically, rolling radius, basically the radius of the wheel in simple term. And that's how we're going to get how much torque we need at the wheel, okay? And once we know that, so typically, as I told earlier, what happens is this, we need to understand very carefully. We have our motor, we have the motor. Motor output will be given to the transmission unit, in simple term, gearbox. Then it goes to those differential, etc. So we're going to say combined arrangement of all this, and then it actually turns the wheel, right? So do note that the gearboxes used in EVs, these generally use a fixed gear, single set of gear, okay? And it is generally torque multiplier gear. Torque multiplier definitely means speed reducer. Right? So let me take an example, not to worry. So of course, I believe most of you are familiar with this gear concept. I'm not going into the details, these are mechanical. So generally, there will be some arrangement like this, a kind of this small radius wheel with some slots, in simple term, there are of course multiple arrangement, and then a bigger radius wheel. So if I rotate it, because of their contact, it will also, the second one will also rotate. So if I consider this first one as a torque of T1 and speed of omega 1, and then the second one having higher radius, let's say it is having T2 omega 2. Okay. So if I assume that these are 100% efficient system, so your T1 omega 1 is going to become T2 omega 2, which is nothing but power. So of course you can understand that common sense wise, if the smaller wheel rotates at speed omega, the bigger wheel rotates at omega 2, which one will be higher? Omega 2 will be higher or omega 1 will be higher? So in this case, omega 2 greater than omega 1 or omega 1 greater than omega 2? What do you think? Which one is correct? The bigger radius has higher speed or smaller radius has higher speed? If I connect this gear arrangement together, which one will be higher? Omega 2 is higher or omega 1 is higher? Let me see your answer quickly. I hope the question is clear. Right. Most of you are saying omega 1 will be higher. Generally, the lower radius one is going to be higher for common connections. I'm not talking about any specific or very complicated arrangement. So yes, typically this omega 1 is going to be higher. So that means T1 will be lesser than T2, right? Because power is going to be constant in both the sides. Power cannot be increased or decreased. I'm assuming 100% efficient system. So power has to be balanced. So if a gear arrangement is increasing the torque, that means at the same time it will reduce the speed, right? So the gear arrangement used in electric vehicle, it is basically a torque multiplier. What does it mean? If I say motor torque is Tm and wheel torque is Tw, okay? And the gear ratio, we call it GR in general, okay? So the way Tm, Tw, it will be done is Tw, torque at wheel, is given by gear ratio into torque at motor. So basically, torque at motor output, this will be multiplied by the gear ratio, okay? And then we are going to get torque at the wheel. Typically, this gear ratio, in my experience in EVs and even for three-wheelers, I saw that typically these range in the quite vicinity of 9 to 12, typically, okay? For example, most of these e-rickshaws, they have a gear ratio of around 10. So then, torque at wheel is going to be 10 times higher than torque at motor. Okay, I hope this point is clear. Torque at wheel is going to be multiplied by the gear ratio number. Typically, they will mention a gear ratio of 9.5, 10, something. There's a fixed number mentioned in the brochure if they disclose it. Vehicle manufacturer, not all of them disclose what exactly they use. But typically, if they disclose, it will be a number. Okay? So torque at motor will be multiplied by torque for the gear ratio, GR. GR is gear ratio. And then you're going to get torque at wheel. So similar way, motor speed, omega at motor, has to be divided by the gear ratio to get speed of wheel. I hope this point is clear. Please note down, we also need to solve problems. So it's very simple. Torque at motor multiplied by gear ratio to get torque at wheel. Speed of motor divided by gear ratio to get the speed of wheel. Now you can ask the question, sir, why you are using torque multiplier? Why we generally don't do the opposite? Why motor torque is on the lesser side than the wheel torque? The reason is basically, as you have seen yesterday's class also, if we want to have higher torque, there are two ways we generally get it. One is you have to use a high magnet strength, right, which is very expensive. Second option is you have to use high current. That is also a bit troublesome, because high current means higher cross section of the copper winding. So even your motor size goes up. Okay. So generally, to achieve higher torque, we go with typically a 1:1 kind of gear ratio. That is easier to achieve, right? In the other side, getting a higher speed from the motor, electrical side there is not much problem, because a speed kind of is proportional to the voltage. Okay. So for higher voltage system, generally we need higher insulation, and that can be managed up to a certain extent. Okay. So that's not a problem typically. And main problem from high speed comes to your mechanical arrangement. As yesterday also some of you are mentioning that between stator and rotor we have a very small gap. How do you manage those gaps, right? As I told you, using some bearings, right? We should connect both rotor and stator, at the same time maintaining some air gap. Now, getting a high speed bearing is also a challenge, right? Because let's say you want to have a bearing of 20,000 RPM at the power level of 100 kilowatt, 200 kilowatt. It's not an easy job. Okay, it has to offer both high speed and high power, high torque. So generally, from mechanical and design constant, that speed limitation comes. Whereas torque limitation comes from the current rating as well as your magnet requirement. So as a trade-off, generally what we do is we prefer to have the motor as lesser torque, then we get the higher torque by providing gear ratio. So to compensate for that, you have to design the motor with higher speed, right? Because you have to achieve certain vehicle speed also. Let's solve one or two problems. It will be more clear. Not to worry.